looking at this expression, I want us to find the value of the unknown, which is x. And with this, of course, to get the values of the unknown, you're going to see that by the expression, we have to the power 2x of 2, and we also have 2x here. But here, 2 is the base and x as power. We also have 2 here as base, and there is also x here as power. So we need to put this in a simple term so that this side, which is the simpler side, relates or looks similar to this particular one. And to do so, we can use the expression like this, 2 to the power x, like this, 2, which is the same like 2 to the power 2x, but because if we use this 2 multiplied by x, we are still going to have the 2x, so that this 2x looks similar to this 2x, which you can see here. So we are going to have plus 3 in bracket 2 to the power x minus 4 is going to be 0. In this case, it is very easy for us to now express. We can therefore say that let 2 to the power x be equal to y. If we state it like this, then of course, any place that we see 2 raised to the power x, we are going to replace with y, which in this case, we are going to have y squared here, and we are going to have 3y here, because the 2x will represent y. So we are going to therefore say that y, which stands for the 2x, then the square which is up here is going to be y squared, as you can see here, then plus 3 in bracket y minus 4 is going to be equal to 0. Of course, by this, the expression has been simplified. So it then brought back to y squared plus 3y minus 4 is equal to 0. It has come to the simplest expression, which we already know, and it's very easy to find the values of y. In this case, what we want to do is to go by method of factorization and express in a way that if we use y and y, we are going to have this y squared. Then what two values are we going to use so that we can have the center value as 3y if we cross multiply it to express? We are going to have minus 1 and 4, so that if we do like this, 4 times y is going to give us 4y plus y times minus 1, that is 4y minus y is going to give us 3y. If it gives us the center, then of course this expression, this first line here, which you can see as y minus 1 is equal to 0, right? Then of course it tells us that if y minus 1 is a factor, then we are going to say that y here is equal to 1. Therefore, y will be equal to 1. Then in this other one here, which is the expression here, that is y plus 4 should be equal to 0. This implies that y is equal to minus 4. Therefore, by using the simplest method of factorization, using the law that states that we should express this side as y squared and find two values to give us minus 4, so that when we express and cross multiply to add them, we are going to have 3y as the finding result, or as the final result, which in this case is true. If it is true, then y minus 1 as this upper factor to tell us that y is equal to 1, and y plus 4 equal to 0 to tell us that y is equal to minus 4. In this case, we now know the values of y, but note that there is an area here which we have let 2 as the power of x to be equal to y. Therefore, we have to represent or replace these y here by the values which we have here as 1 and minus 4. This would therefore implies that from this area, which is 2 to the power x equal to, now we know y as 1, we are going to represent like this, right? So 2 to the power x is equal to 1. To get the value of x, what are we going to do? In this case, you're going to say that to get the value of x here, we are going to say what raised to the power as base of 2 is going to give us x. So in this case, we can easily use the law of indices to get the value of x, which must have the same base as 2. So what we are going to ask ourselves is, what if we give it a power as the base of 2 is going to give us 1, which is the one which is here. By using the law of indices, we know that 2 raised to the power 0 is equal to 1. That is, anything raised to the power 0 is equal to 1. In other words, the reason why we must use 2 is because it should have the same base as this one on the left-hand side. Therefore, this expression is the same as 2 to the power x is equal to 2 raised to the power 0. Because 2 raised to the power 0 is the same as 1, since we already have 1 here. And since we know that 2 raised to the power 0 is the same as 1, as we have here, then now we have the same base. We have 2 here, we have 2 here. Therefore, if the base are the same, therefore the power must also be the same. If 2 is equal to 2, then x must be equal to 0. Therefore, x in this case is equal to 0. That is the value of x. And of course, we need to also use that for y as equal to minus 4. In this case, what we want to do is to come back here and use the expression that states, as you can see here, that 2 raised to the power x is equal to y, which is minus 4 this time. Of course, we need to use something that has the same base as 2, for which if we raise the power, we are going to have, of course, negative 4. In this case, there is no value that is going to exist, because the only value here that if we raise to the power is going to give us 4, which the base must be 2, is 2. If we use 2, in this case, raised to the power 2, we are going to have 4, for which in this case it is minus 4 instead of 4. But if at all, we could have had something like this, 2 to the power x is equal to 4. Let's assume that if our y here was equal to minus 4, or our y here was instead 4, and we actually have this, then the value of x here will be 2, because if we express to have the same base as this, then we are going to have 2 raised to the power x will be equal to 2 raised to the power 2, which if in the same base, then the power also must be the same, which if you have cases like this, then x will be equal to 2, as you can see here. But here, as our real answer here, there is no value if we raise to the power is going to give us minus 4. So in this case, the only true value of x here is 0. So in other words, in this case, the only true value of x is equal to 0, because having this base, the only thing that expresses itself is 2 to the power 0 to give us 1, which have the same base as this. Therefore, since the same base, then the power must be the same, which is x equal to 0. And now, knowing this, I want us to refresh our mind again with some of the laws of indices. And of course, looking at the first law, it states that a, as you can see, raised to the power 2 times a raised to the power 3 is the same as a raised to the power 2 plus 3, which is equal to a to the power 5. Now, another rule here states that if a raised to the power 3 is divided by a raised to the power 2, then of course it is the same as a raised to the power 3 minus 2, which is equal to a raised to the power 1, which is the same as a. Now, there is another rule here that states that when it is raised to the power negative sign, it is the same as 1 over a to change it to a positive sign. Then when it is in the form of root, like a to the power 3 over 4 in this kind of power, we try to put it in root form, which is similar to a in root, right, 4, then 3, as you can see here. Then, of course, we have this particular one, which we have just used here, that anything raised to the power 0 is equal to 1. It is the law that states that, for example, a raised to the power 0 is equal to 1. This is the law which we have just used here. By making sure that we try to use this here, since we have this area of 2 to the power x equal to 1, we're looking for something which, if we raise to the power, is going to give us 1, which in this case is 2 to the power 0. You can see a to the power 0 is equal to 1. It means 2 raised to the power 0 is equal to 1. Any number, even 10 raised to the power 0 is still 1. 5 raised to the power 0 is still 1. But we must use a value which is equivalent to the base for which this side is carrying the x, which the only case here is 2, to make x to be equal to 0. So this was the law which we apply in this particular area. So if you want to see more questions and solutions based on these, then of course you want to make sure to check the website link below this video description. See you again in the next upload, and bye-bye for now.